The potential of highly mechanized combat units has been developed to a degree where they are of preponderant importance in the expedient execution of tactical engagements. Conventional transport airplanes, supplemented by gliders, have been used to tactical and strategic advantage in transporting assault troops and material. The use of gliders for the establishment of airheads in Europe during World War II reveals several serious deficiencies, such as 1. The low landing speed of the glider made it particularly vulnerable to enemy ground defenses during a landing. 2. The inability of the glider to go around or at least choose an alternate spot because it had no power. 3. The large landing area required to avoid traffic congestion during assault operations. 4. Wings of the gliders would snag on trees, fences, bushes, and other wrecked gliders, causing crack-ups which often prove fatal to the entire glider load. The Airborne Task Force carrier has been conceived to remove these inherent disadvantages and permit greatly expanded airborne assaults. Early design studies accomplished by the Design Branch, Aircraft Laboratory, Air Materiel Command, considered aircraft that would land, taxi to an unloading spot, and lower its fuselage section by means of winches. This developed into the concept of the droppable pod. The droppable pod would be capable of transport by the same carrier aircraft, but would be released near the ground at speeds in excess of 100 miles per hour and skid to a stop with the aid of auxiliary decelerating devices. After separation, the pod would be without its wings, but until it actually was separated, this pod, in a sense, would retain a choice of landing strip. Actual development of pod-type aircraft was started in February 1946 at Wright-Patterson Air Force Base in an effort to expand airborne assault and supply and to remove the inherent disadvantages of existing equipment. The Fairchild XC-120, a twin-engine plane with detachable fuselage, is the Air Force's latest evolution in aircraft design along these lines. The XC-120 can land, remove its cargo-carrying pod, and leave it for ground crews to unload and reload as time and conditions permit. From a logistical standpoint, this will save precious time, provide greater mobility, and reduce loss under enemy attack. Exploratory tests were considered advisable before undertaking extensive full-scale droppable pod development. Here is a model of the test pod and B-26 airplane which was used as the test vehicle. The pod was suspended from a standard bomb shackle and the release control was operated by the pilot. A skid-type landing gear, approximately the length of the pod and suspended on shock-absorbing struts, was first attempted. Testing up to 70 miles per hour demonstrated the fundamental defect of this configuration. With the skid force well forward of the center of gravity, the pod had insufficient directional stability, and any disturbance directionally produced a tumble. It was therefore decided to introduce a swiveling nose wheel with skids mounted aft in the conventional tricycle gear manner. The skid tread was increased considerably to improve rolling stability. In addition, an extensive retest was accomplished on smaller shock absorbers to obtain the proper characteristics. To evaluate pod performance during actual tests, 3 motion picture cameras were used. One high-speed camera, mounted in the aft fuselage, photographed the pod during release from the airplane and contact with the ground, and provided detailed information on the operation of the shock struts. A second camera was mounted on the pod's support rack and photographed the directional path of the pod during its deceleration phase. The third camera, located on the ground, photographed the general behavior of the pod and provided detailed information on its longitudinal attitude during deceleration.